Earth, our bustling home amidst the vastness of space, surrounded by a symphony of satellites orbiting above, aiding our communication, exploration, and understanding of our planet. But here's the kicker. While we go about our daily lives, Earth is on a whirlwind journey through space, spinning at 1,000 miles per hour and hurtling around the Sun at a mind-blowing 70,000 miles per hour. Now, let's journey further into the depths of our solar system. Beyond Earth lies the asteroid belt, a realm filled with millions of rocky bodies, and beyond that, the mysterious Kuiper belt, home to trillions of comets, each with its own tale to tell. But here's a question to ponder. Have you ever wondered how our solar system moves through the Milky Way galaxy? It's a dynamic dance of celestial bodies, with our solar system traveling at a 60-degree angle between the galactic plane and the planetary orbital plane. Join us as we uncover the secrets of our solar system's cosmic journey, from its bustling activity to its mesmerizing motion through the Milky Way. And don't forget to hit that subscribe button to join us on future cosmic explorations. Let's dive into the wonders of the cosmos together. The entire solar system is moving around the galaxy in a clockwise motion at about 500,000 miles per hour, and it is doing so at about 60 degrees from the galactic plane as seen here. Let's zoom out so you can get an idea of its positioning in the galaxy. Additionally, we actually bob above and below this galactic plane over the course of about 60 to 70 million years. Right now, we are a bit above the galactic plane and we are heading up, and in 15 million years or so, we will start to head back down. With all this in mind, it's moving in a way that I never really thought about until I saw a video on it. While this is not to scale, it gives you a good understanding of the movement. The Sun is cruising around the galaxy as the planets rotate around the Sun. The planets and Sun are on the same plane, so they are not being dragged behind the Sun or forming any type of wake or vortex. But this is still a great depiction of the solar system's movement around the galaxy. The solar system itself is wrapped up in a giant protective bubble called the heliosphere. It helps shield us from dangerous incoming galactic radiation, and our solar system actually has a tail. This heliotail is made out of solar wind plasma and magnetic fields. While not depicted perfectly here, it does stream out from the Sun in all directions. While some believe it is more like a comet with a tail, there are other models of our protective bubble. But the heliosphere is not the end of the Sun's influence. Beyond the heliosphere, there are more objects under the gravitational influence of our Sun. The theoretical Oort cloud is an immense spherical cloud surrounding the planetary system and extending approximately 1 light-year from the Sun. It is 1,000 or 2,000 times bigger than the orbit of Neptune. Moving out, we can see that the entire solar system is moving through an interstellar medium of very low-density hydrogen gas. More specifically, we are moving through the local interstellar cloud. Alpha Centauri and Sirius are also pictured here. The entire cloud is about 30 light-years in length, and its movement is indicated by the blue arrows. As we move out, we see our local interstellar neighborhood. It's approximately 50 light-years across and contains about 1,000 star systems. Many of these stars also have their own family of planets orbiting them. We are orbiting the galaxy at 137 miles per second. Most other stars are also orbiting the galaxy at roughly the same speed, but the stars around us are also moving randomly relative to one another. So that means that the distances between the stars around us are not fixed and they pass by one another from time to time. The position of stars in the sky appears fixed to us on small time scales, but they are moving and interacting. It's a dynamic and ever-changing system. About every 50,000 years, a star will pass near our solar system. That may not sound very frequent, but over the time that light has been on this planet, 80,000 wandering stars have passed near our solar system. It was recently discovered that a small binary star system shows a star passed through the Oort cloud about 70,000 years ago. It would have looked much bigger than a normal star in the night sky. Could these close encounters provide a chance to visit other star systems and planets? Could these close encounters have enabled various life forms to spread across the galaxy more easily? With all this in mind, we are doing this dance around the Milky Way galaxy with some 300 billion other star systems, each of them containing their own planets. We are not just in our own little isolated bubble, we are connected to the solar system, local star groups, and the Milky Way, like little atoms speeding around the galaxy center. Are we part of a larger, more complex entity? Let's continue our journey. If we zoom way out from our interstellar neighborhood of 50 light-years to about 1,000 light-years across, we can see what's known as the local bubble. This area, which, keep in mind, has about 7 million other stars cruising around in it, is called the local bubble because it doesn't contain a lot of gas and dust. This bubble was created by a series of supernovas 14 million years ago. A supernova occurs when a massive star dies. When it dies, it explodes and pushes out gas and debris in all directions, leaving behind a supernova remnant. At the edge of the bubble created by the supernova, gas and dust fall in on itself due to gravity, and new stars are born. This bubble isn't specific to us, we just happened to fly into it about 5 million years ago. There are likely hundreds of thousands of these explosion creation bubbles spread out in the spiral arms of the Milky Way, bouncing into each other and interacting in fascinating ways. Like these newborn stars, our solar system formed with thousands of other stars and giant clouds of gas and dust. During the early days of the universe, the only elements around were hydrogen and helium. When enough of these elements coalesced together under the force of gravity, the first stars were formed. From those early stars, heavier elements like iron were created and then spread throughout the cosmos. When new stars were forming out of these elements, planets like ours with iron at their core were possible. So I'm not exaggerating when I say that other stars gave birth to our sun and our planet. But what are your thoughts about this exploration? Comment down below and subscribe to our channel for more similar videos.